Okay, today we'll be working on chapter 7. It's called the confidence interval. There are 3 parts on this chapter. We are going to work on the first part today, and then part 2 and part 3 in next class. We are going to start with some basic terms related to the confidence interval. The first one is called the point estimate, a very important term that you need to know here. When I say point estimate, it is a specific numerical value estimate of a parameter. So what we are doing here is, if we want to know about the population, say for example, I want to know the GPA, okay, the average GPA of all students at CCA. If I want to do that, it is impossible for me to get the data of each student. So what I'll do is, I'll take a sample, and then from that sample, I'm going to find the average. So the actual average, or the true average, which is also called the parameter, will be a little bit more or less than the mean of the sample. So in that case, the mean is the point estimate. So you can say that the actual GPA of all students at CCA is a little bit more or less than the average GPA for your sample. That's why we define the point estimate as a specific numerical value estimate of a parameter. And the best point estimate for the population mean is the sample mean. So if we want to estimate the population mean, this is the key here. If you want to estimate the population mean, we estimate using the sample mean. So sample mean is the point estimate. Sample mean is your point estimate. So this is your point estimate. So meaning of that is, you can add this there. You have the point estimate in the middle. Okay, you have the point estimate in the middle. The actual mean of the population will be a little bit more than that. So maybe it will be X bar plus some value. Okay, mean plus some value, it may go up to that, or it will be mean minus some value. Mean minus some value. We can write mean minus some value. ME I am writing. So this value that we are adding or subtracting, this is called the margin of error. That's why I'm writing ME. So if your value is here, okay, if the sample mean is here, the true mean will be a little bit more than that, or little bit less than that. So we can say that the true mean is somewhere between these two values. Here is your mean. The true mean lies between these two values. So that is the meaning of the point estimate. Next thing that we need to study here is called the interval estimate. Next key thing that we need to know here is the interval estimate. So an interval estimate of a parameter is an interval or a range of values. So you can see here, when I was talking about the point estimate, we have the estimate in the middle, and we have the actual value that lies little bit above that point estimate or little bit below that point estimate. It lies in this interval. So this interval or this range of values, it is called the interval estimate. An interval estimate of a parameter is an interval or range of values used to estimate the parameters. This is your interval of estimate. This estimate may or may not contain the value of the parameter being estimated. We cannot exactly guarantee whether the actual parameter lies in this one. So later on, what we start saying is, we'll express the interval with certain confidence. Like we'll say, I'm 95% confidence that we have the actual value that lies here, or I'm 99% confidence that the actual value lies here. Or we say that it lies in this region with certain confidence. So if we say that, then we say that this interval is the confidence interval. So that is the idea of interval estimate. So we have seen that we'll have the point estimate in the middle. So let me draw that here again. we have the point estimate in the middle, then the true mean lies little bit above that or a little bit below that, or it will be a little bit more maybe. Okay, it will be a little bit more or it will be a little bit less. So x minus the margin of error. So what I'm trying to say here is the actual mean lies here in this interval. And if we can explain this with certain confidence, then we say that this interval is the confidence interval. So confidence interval, in order to define the confidence interval, we need to know what is confidence label first. So the confidence label of the interval estimate of a parameter is the probability that the interval estimate will contain the parameter, assuming that a large number of samples are selected and that the estimation process on the same parameter is repeated. So what we do is, in order to estimate the true population in the given interval, we construct these type of intervals using different samples. And then we say that the actual population mean lies within this range with certain confidence. That is called the confidence label. And when I say the confidence interval, it is a specific interval estimate of a parameter like this interval here, determined using the data obtained from the sample. Because in order to construct the confidence interval, we need the sample, because in the middle, the point estimate comes from the sample. This X bar is the sample mean. And by using the specific confidence label, so when I say confidence label, there are three commonly used confidence label, like 90%. Meaning of that is, with 90% confidence, we can say that the true mean lies here. Or with 95% confidence, we say that the true mean lies here. Or with 99% confidence, we can say that the true mean lies here. So whenever we say confidence interval, it is not just the interval, but also we are mentioning that the true parameter lies in that interval with certain confidence. You will be certain percent sure that it lies there. So that is why it is called the confidence interval. So part one for this chapter, it is the confidence interval for mean when population standard deviation is known. So we are talking about the confidence interval for mean. We have to find the interval for mean, or we have to say that the population mean lies from here, certain minimum value up to maximum value. When you know the population standard deviation, this is the first case. And what we already know is, this is what we know. You can write this down like before. You have the point estimate, that is the mean in the middle, and the actual mean lies a little bit above that or a little bit below that. So it will be X plus the margin of error or X minus the margin of error. The true population mean lies in this interval, and this is called the confidence interval. We'll add certain percent confidence there. So you can see the confidence interval for the estimation of population mean. We want to estimate the population mean. How much is the mean? It lies from here up to here. So it will be the point estimate, that is the sample mean, plus or minus the margin of error. Sample mean is here, so we add or we subtract, plus or minus margin of error. Or we can also write like this: the mean mu lies between, when you see this value in between, lies between the mean minus the margin of error. Okay, mean minus the margin of error, you can see, and it goes up to mean plus margin of error. This is second way of writing the same interval. You can write the interval like this using plus or minus, or you can write the interval like this. Or sometimes we also write like this. Or you can also show this. We go from X minus margin of error, X minus margin of error up to X plus margin of error. Sometimes we also write the interval like this, like in algebra. So it goes from X minus margin of error here up to X plus margin of error. Now, you know what is this? The point estimate is the mean. That is easy to calculate. Point estimate is the mean. It is easy to calculate. But what is the margin of error? This is something that we need to know. How do we calculate margin of error? Very important. When we want to calculate the margin of error, this is equal to Z alpha over 2, or we call this Z critical. Simply we write ZC sometimes, okay? We write Z alpha over 2 or ZC multiplied to this value, the standard error that we know from the central limit theorem. So Z sub C times the population standard deviation divided by the square root of n. If we do this, we get this margin of error. So once we have the mean, then we can add and subtract to get the interval. So please write this formula here. Margin of error is calculated using the formula Z sub C times the population standard deviation divided by square root of n. So this is the first set of formula that you need to know. There's a second formula that we need to know. Sometimes we know the critical value or we know the confidence level. Okay, we want certain confidence level. I want to predict the true mean with 95% confidence level. Say, for example, 95%. So if I know the confidence level, if I know the population mean, population standard deviation, and if I know the margin of error, in that case, if we want to estimate the size of the sample, we use this formula. So sample size is equal to Z alpha over 2, or you can also write Z sub C, it is the same thing, times sigma divided by the margin of error. This is the second formula that we'll be using in next two examples. These are the two important formulas that we need to know. Example, the age when smokers first start from previous study is normally distributed with a population standard deviation of 1.8 years old. A survey of smokers of this generation was done to estimate the mean age. The sample of 35 smokers found that their mean starting age was 14.7 years old. Find the 95% confidence interval for the mean. Okay, here we need to know something. Let's find out what is given. The age when the smokers first start from the previous study is normally distributed. So we are talking about the age of the smokers when they start smoking. So if we study everyone, that is the population, it is found that the population is normally distributed with the population standard deviation of 1.8 years old. So that is the population standard deviation. Sigma is given. Okay, standard deviation for the population is given. Population standard deviation is 1.8 years. So when population standard deviation is given, that is our first case, sigma is given. A survey of smokers of this generation was done to estimate the mean. We want to estimate the mean. That's why the survey is done. What is the mean age this generation started smoking? We want to estimate that. So for that, what is done is the sample of 35 smokers. So that is your n equal to 35. That's your n is 35. Let me use different color for the later. N. They found that their mean starting age was 14.7. So the study found that from the survey, the mean starting age was 14.7 years old. This is the mean. So that is the sample mean X bar. That is your sample mean X bar. We have to find the 95% confidence interval for the mean. Now here, we want to find the confidence interval, but you must be 95% confidence. So this is what we want, 95% confidence interval of the mean. So what we already know is if I want to find the confidence interval, I need the X bar in the middle. I need the X bar in the middle, which is called the point estimate. So here the point estimate is, let's find that. Here, point estimate, you can write this down. Here, point estimate, which is X bar, the sample mean is equal to, it's given in the problem. Sample mean is 14.7. That is given to you. 14.7. So sample mean is given to you. That is a point estimate. Now what I need is I need the sample mean plus some value and sample mean minus some value. So I need the sample mean plus the margin of error, and I also need sample mean minus the margin of error. I need these two values. So what I actually need is the margin of error. Now the margin of error, if you look at your formula from the previous slide, margin of error is equal to Z sub C times population standard deviation divided by the square root of n. Now, if you look at this question carefully, you have the population standard deviation. It's 1.8. You have the sample size n is 35. But we don't have this Z sub C. We don't have the z-score at given confidence interval. That's the meaning. Z sub C, we don't have that. So what we are going to do is we are going to use the normal distribution and we are going to find this Z sub C. So let's find this together. So when I say 95% confidence interval, meaning of that is in your normal distribution, the area in the middle, this is the 95% area. This is 0.95. This area is 95%. That is the meaning of that. This is your 95% area. And what I want is Z sub C. Z sub C is this Z score here. This is called the Z sub C. So that the value on the other side, this one will be negative Z sub C. Negative Z sub C. I know that this area is 95%. So out of 100%, 95% is here. So on the tail here and here, the remaining 5% is divided into two parts. So here we have the 95%. So remaining 5% is divided into these two parts. That is, this will be 2.5%, this will be 2.5%. So we can label that. This is at the tail, that is 2.5%. So let's label that. This area is 2.5%, that is 0.025. And this one here is also 0.025. So once we have the area on the tail, we can easily find this Z sub C. So what we already know, in order to find the z-score, we use the inverse normal, if you remember. It is inverse normal in our calculator. Inverse normal, we need the area in order to use the inverse normal. You have to be very careful here. We want this Z sub C. So if I want Z sub C, I want all area to the left of that. So all area to the left of that, you may use your calculator to add this. From here up to here, the area is, you can see this area is 0.95. And area over here on the left tail is 0.025. So if I want 0.95 and 0.025, that is 95% and 2.5%, it is 97.5% or 0.975. That is the total area to the left of Z sub C, because whenever you are using the inverse normal, you need all the area to the left of that. Now the mean for the z-score, the mean is 0. Standard deviation is 1 for a standard normal distribution. Whenever we are talking about z, we are talking about standard normal distribution. Now you can use your calculator to evaluate this. So if I use my calculator to evaluate inverse normal, 0.975, mean 0, standard deviation 1, I obtain 1.96 in my TI-84 calculator. So we have Z sub C is 1.96. We need this, and we were calculating this because we were about to calculate the margin of error, and we don't have that value. That's why we did all this calculation to get this value Z sub C. So let's substitute here. So Z sub C, we just got 1.96, then multiply to this one. The population standard deviation here it is 1.8, 1.8, and we have to divide that by the square root of n. N is 35. Now, I want you to use your calculator to simplify this one. I simplified here and I got 0.3043. That is the margin of error. Yes, the actual value after this simplification should be 0.5963. So that is the margin of error. What we are looking at is we want to find the confidence interval. So you can see here, in order to find the confidence interval, we need to know that we need two values. The first one is mean minus the margin of error, and the second is mean plus margin of error, so that we can say the true mean lies between these two values. So this is where the true mean lies. That's why we need the mean minus margin of error and mean plus margin of error. So in next step, we are going to calculate those two values. So this implies mean plus margin of error. Let's do minus first. Mean minus margin of error is equal to mean, or the point estimate is 14.7, 14.7 minus the margin of error, which we just obtained here, 0.5963. So we are going to subtract that in calculator. 14.7 minus 0.5963, and we get 14.1037. So that is the mean minus the margin of error, this lower value, the lower end of the interval. We also need the upper end of the interval. It is mean plus margin of error. So let's do that. Mean plus margin of error. Mean is 14.7, or the point estimate is 14.7, plus the margin of error is 0.5963. So if we add, make sure you add that in your calculator. So when you add, you should get 15.2963. So the lower value for the interval is 14.1037, and the upper value is 15.2963. So meaning of that is, with 95% confidence, see, we are calculating the 95% confidence interval. We use that 95% to calculate this Z sub C, which we use here. So with 95% confidence, we can say that the true mean age the smokers will begin smoking lies between these two values. That's what you need to write as the conclusion. So let's write that down. With 95% confidence, we conclude that the true mean lies between 14.1037 years and 15.2963 years. Example, you are interested in estimating the mean age of the citizen living in your community. In order to do this, you plan on constructing a confidence interval. However, you are not sure how many citizens should be included in the sample. If you want your sample estimate to be within 4 years of the actual mean, with a confidence level of 96%, how many citizens should be included in your sample? Assume that the standard deviation of the age of all citizens in this community is 25 years. Okay, let's find out what is given and what we need to find. So they say that you are constructing a confidence interval So whenever you are constructing the confidence interval, you know that you have the point estimate in the middle, which is the sample mean in this case. And if you look at this, you may see the sample mean if it is given. If not, you don't have to worry about that. So we need the sample mean in the middle for the confidence interval. Then you need mean plus margin of error on that end, and this end you need the mean minus margin of error, so that the true mean lies here, lies between those two values. But what they say here is the true mean, if you want to estimate to be within the 4 years of actual mean. When I say within 4 years of actual mean, see, within 4 years of actual mean, meaning of that is the true mean lies 4 years above or 4 years below the point estimate. So meaning of that is this 4 years is the margin of error that's given to you. So let's write that down. Here, the margin of error is 4 years. That is given to you. You want the true mean to be within 4 years of actual mean. So that is mean plus 4 years and mean minus 4 years. So that is your margin of error with a confidence level of 96%. So confidence level of 96%, meaning of that is the area in the middle of your normal distribution will be 0.96. So C is equal to 0.96. How many citizens should be included in your sample? So we want the sample size. And they have given the standard deviation of all citizens. When we say all citizens, that is the population standard deviation, is 25 years. So they have given the margin of error. They have given the C value, which is 0.96, C equal to 0.96, 96%. And they have given the population standard deviation to be 25 years. This information is given to you. So after we have this information, as you have seen, we want how many citizens should be included in your sample. Meaning of that is we want sample size. If you go back to your previous slides or your notes, you'll see that the formula to find the sample size n is equal to z sub c or z alpha over 2, which is same thing. So z sub c multiplied to sigma divided by margin of error squared. That is the formula. So if you look at the formula, you have the margin of error. It's here. You have this population standard deviation. It is here. We don't have z sub c. So first, we need to calculate the z sub c using the standard normal distribution. So in this case, we have the 96% confidence interval. So the middle area is 96%. You can label this. You can draw the standard normal distribution. So that area in the middle is 96%, 0.96. This is the 96% area. Now, what we need is we need z sub c, that is the value here, that is your z sub c. So this value here will be negative z sub c, negative z sub c. In order to find this z sub c, I need all the area to the left of that, but we are missing this area on the tail. This is 96%, so the remaining 4% is divided into two tails. So 4 divided by 2 is 2%. So this area is 2%, 0.02. And the equal area is here by symmetry, which is 0.02. So area on the tail is 0.02. So if I want this z sub c, you know that z sub c is equal to, we use the inverse normal. In order to find the score, we have to use the inverse normal. So inverse normal, the area from here all the way to the left, the area is 96% here and 2% here, or 0.96 plus 0.02, that is the 98%, or 0.98. Mean is 0, standard deviation is 1 for standard normal distribution. So use this in your calculator or type this in your calculator. you should get Z sub C is equal to 2.0537. That is Z sub C that we are looking for. So we have Z sub C. Let's plug in back here. Let me do it in next step. So N is equal to, your Z sub C is 2.0537. We have to multiply that by the standard deviation, which is 25. We have to divide that by the margin of error, which is 4. Close that parenthesis and hit square. N equal to. Now, let's type this in our calculator to see what we'll get. So we'll begin the parenthesis, we'll type everything inside, close the parenthesis and square it. And I get 164.7533. So meaning of that is we are looking for the sample size. Once we have the sample size more than 164, whenever it is more than, it is 164, then you are selecting something. Meaning of that is you are selecting 165 individuals. So you always have to round it up. So this is 165. So the required sample size, how many citizens, see our question was, how many citizens should be included in your sample? So you can easily say that 165 individual should be included in the sample. So let's write that down. So 165 citizen must be included in the sample. Okay, that is the conclusion. We were looking for the N value and we got it here. So 165 citizens must be included in the sample. So that is the end of this example.